So, good morning, everybody. Just a quick note. So I think the overall grades in the exam too, they were good for the whole class. So that's a good thing. And I just wanted to remind you something that I mentioned since the beginning of the semester. Usually students have more trouble in some more technical parts of this course, or how to calculate some rates. And that's exactly the topic that we're going to start today. So in the fertility chapter that we're going to continue today, I will explain how to estimate some fertility rates, reproduction rates, and make the distinction between them and so on, show some examples in Excel. And also in the next chapter, when we talk about mortality and I explain how to estimate life expectancy at birth and also in other age groups using life tables, that's usually where students have more trouble. So I think it's really good to keep the focus on the course. And so here we will just continue now on the fertility chapter, and the idea is to cover the fertility and mortality before the next exam, and then cover internal and international migration by the end of the semester, right? So that's the goal that we have now, pretty much these 4 major chapters that goes a little bit more in depth on these demographic components. Cool. So in the fertility chapter, I talked a little bit about it at the end of our last lecture before the exam. And I just gave you some explanation of the different studies, different kind of studies that we can do about fertility, and also talking about some major differences in these concepts of fertility, reproduction, fecundity, and also childbearing years that we usually take for women as the standard between 15 and 49. And sometimes we even reduce it to 15 to 44 because in more developed countries, there is like really few women having children between the ages of 45, 49. But when we compare usually across countries or even within countries, we use this age range between 15 and 49. Some fertility terms that are important for us, the same way that we kind of discussed other terms in mortality before and some other even in fertility already and in migration, it's important for us to understand exactly what these concepts mean. So fertility is the actual production of births, how many children women are having in a specific population, a specific time point. And fertility, it's related to all children that they're having, both boys and girls. Reproduction, whenever you're talking about reproduction, we are talking about how many daughters women are having on average in a specific population, specific time point. And that's going to be more clear when we talk about the different rates that we will discuss here in this chapter. Infertility is child death, women or people not having children, either voluntarily or involuntarily. And fecundity is the biological ability to reproduce, to have children. But within fecundity, there is the subfecund categories that some people like, and usually when we talk about fertility, we focus on the analysis of women because they are the ones that provide more reliable information about the number of children that they had. And that's usually standard. But again, as we discuss in this chapter, male fertility has been a growing topic of research, but usually when we are talking about these concepts focusing on women, and within fecundity, we have the subfecund categories. That's pretty much possibility of women being definitely sterile, probably sterile, semifecund, a fecundity indeterminate. And completely infecundity is when women cannot have children at all, right? Menarche is the beginning of the female reproductive period when they have the first menstrual flow. Why is important? because that's when they are able to get pregnant and have children. So if there are different ages, average ages of menarche in different populations, that can affect the level of fertility. Menopause, end of reproductive period, termination of menstruation, so women are not biologically able anymore to have children. And again, if there are major differences in the average age of menopause across populations, that can affect the levels of fertility across these populations. And the postpartum period is usually something that I will mention here when we will talk about which are the factors that might influence the levels of fertility. So the postpartum period is the period of infecundability following a pregnancy, which is a function of the duration and intensity of lactation. So right after women have children, during the period that they're breastfeeding their babies, they are really, chances of getting pregnant is really, really low. So that's taken as we have populations in which women prolong the time in which they breastfeed their babies, then there is a chance of impacting negatively fertility because they will not have children, they will not get pregnant while they are breastfeeding their current baby, okay, their current child. So these terms here are important because it tells us different periods, different moments in which women might be more likely to have children, less likely to have children. And the postpartum infecundability is pretty much that period of time in which women are not likely to have children because of breastfeeding. And breastfeeding, the time of breastfeeding changes across societies. So that's why that's an important thing to know. If we see similar societies in level of development, but one woman tend to breastfeed their children for a longer period, that might have an impact on fertility. Fertility might decline more than in other places. And now I will start here with the indicators that I will discuss throughout this first portion of this lecture. One major indicator, the simple one that we usually hear, and I already talked about it in previous lectures, related to people being born in a specific country, is the crude birth rate. The crude birth rate is cross-sectional. We get information from a specific population, a specific time point, in a specific period. Remember the axis diagram, right? The axis diagram, year in the horizontal axis, age in the vertical axis. In a specific time point, we get information for all people in that population, for all age groups. And here we are counting how many births happen in that population, that specific time point. And we divide that number by the overall size of the population. So we get the overall number of births and divide by the population. Since this number is usually really small, we multiply it by 1,000. And remember, we are getting here the denominator when I discuss the differences between rate and probability. Rate, the denominator of the rate, I should have that demographic concept called person years. So if someone was alive in January of 2020, and that person died in November of 2020, that person should enter in the denominator of a demographic formula only 11th divided by 12. So be this fraction. If someone was alive from January to December, that person would count as one unit, 12 months divided by 12. If we have a baby being born in July and that baby is still alive in December, that baby would count 6 divided by 12 in my denominator, right? So person years, I'm counting exactly the amount of time that people are exposed to the chance of experience the event being measured in the numerator. So the denominator, the correct denominator of demographic formulas, demographic rates, are person years. But it's really hard to find that information, right? If you get in a population, we usually go in a specific month of the year and get the information of the size of population. I cannot get information of the size of population from January to December and know for each individual if that person was alive from January to March, from January to June, or if that we had a baby born in March and the baby died in August. So we cannot do this exercise easily to calculate the perfect denominator for these rates. So instead of having that, I mentioned to you that in rates, we use the population, the mid of the period, usually the population in July. We get the population in July and use it as the denominator of our formulas. The population in July, when I get that, I have the assumption that mortality and fertility are happening in the same level, both in the first half of the year and in the second half of the year. And that population in the middle is kind of like having similar trends of fertility before and after them. If I have the population in January and then in December, I can take the average of them, but still with the assumption that fertility and mortality levels and patterns are happening the same way throughout that year. Right? So to simplify, demographers just use the population in the middle of the years as an approximation for person years. What's the correct denominator for probability? The population in the beginning of the year. Out of everybody initially exposed to experience the event in the numerator, how many experienced it? So that's the population in the beginning of the year is the probability. This difference between rate and probability is really important to understand. So that's why I'm kind of like going back a little bit on what we discussed in previous chapters. And it's going to be really clear when we estimate life expectancy. Because life expectancy use life tables. We usually get mortality rates by age group. We transform the mortality rates into mortality probabilities by age group. And then we go on to estimate life expectancy. But overall, the concept of person years is important for us to estimate the denominator of rates. In the crude birth rate, I pretty much get all babies that were born in a specific population in a specific year and divide by the whole population, including men, right? So here I have both men and women, and here I have both boys, boys and baby girls, okay? So it's called birth rate, crude birth rate, overall population in the denominator. And these are the trends of the crude birth rate in the US since 1950 and projections until 2100, declining from around 24 births for every 1,000 people in the US back in 1950, and expected to be around a little lower, like around 11 births for every 1,000 people by 2100. So this graph I showed to you guys before. The problem with the crude birth rates is that if we have a really young population, a lot of children in a specific population, children don't get pregnant. I mean, fertility of women below 15 years of age is really, really small. On the other hand, if you have a really old population, women older than 49 years of age, the probability of getting pregnant and have children is also really small. So depending on the age structure of the population, we can bias the information about crude birth rate. If we have a really young population, a really old population, maybe our crude birth rates would be artificially low. But as these children get a little older and they're a bigger group, then the crude birth rate we expect to increase, because then you have now more women in reproductive ages. So the crude birth rate is a really simple measure about fertility, but it has these limitations as the one that I just mentioned. One other still simple measure of fertility is the general fertility rate, also cross-section. We get information for the population in a specific year, specific time point. And the general fertility rate, see the difference. The difference is the denominator. Instead of getting the whole population, including men and women of all ages in the denominator, now we get only the female population in reproductive ages, those between 15 and 49 years of age. So because that's the group that's more exposed to the risk or to the chance of having children. Also multiply by 1,000 because the number is really small. And if usually for developing countries, you might not have information about specifically the female population in reproductive ages. So if you just have the number of births and the total population not broken down by the specific age group and by sex for women only, you can get an approximation of the general fertility rate by multiplying the previous crude birth rate by 4.5. But usually countries nowadays, they report the population by sex and at least for this major age group, right? So the general fertility rate now takes into account that not all people are exposed to the chance of having children, and focusing on women because of reliability of the data, and taking out children and taking out older women. Oh, but there are children between the ages of 10 and 14 having children. They are women older than 49 having children. But usually, as I mentioned before, the standard that we take to estimate these fertility rates for fertility rates for women is between the ages of 15 and 49. So these are the trends of the general fertility rate and the overall number of births between 1920 and 2013. The overall number of births in millions increased exactly right after the World War II, and then it declined, and then increased a little bit again in after the 1970s, after the mid of 1970s. Like in 1980, started to increase, and increasing again up to now. It decreased a little bit, like between 2010 and 2013. So this number here, this trend here, the blue curve, and the unit is here in the vertical left axis, is just the numerator of the formula. Is the overall number of babies being born, both boys and girls. And if you just look at the green, at the blue line, you might think, oh, fertility is increasing in the US since the 1970s. But it's not taken into account that actually the population as a whole increases. So now you have more women in reproductive ages between the ages of 15 and 49. So for each one of these time points, if we get this number here in the numerator and divide it by the female population between the ages of 15 and 49, then you get the general fertility rate. And that's this vertical axis here on the right. That's the rate per 1,000 women between the ages, and you see here, between the ages of 15 and 44. Not even 15 to 49, because as I mentioned in the previous slides, in more developed countries, the chances of having children, the incidence of having children between the ages of 45 and 49 is really small. So in this graph, the denominator for the general fertility rate is only women between the ages of 15 and 44. And then you see, yeah, even considering the size of the female population in childbearing years, the general fertility rate increased after World War II. There's the baby boom. But then it declines from the 60s until mid-70s. And then after that, it kind of like has been stable. It has not increased, as we would be misled by only taking the numerator of the formula into account. So the rate shows us that fertility has been kind of like stable if we take into account the general fertility rate, right? From the mid-70s until 2013. Of course, if you zoom in this portion here of the graph, you see some increases, declines, increases, declines. So we start to be more susceptible to explaining small changes in our demographic components, because now we don't see these huge changes anymore. And any small change that we see over time, and if we zoom in into that portion of the graph, we try to understand why that happened, right? And then I just mentioned to you guys the chance of having children. It's really small for children, those below the age of 15. Oh yeah, there is fertility for those between 10 and 14, but it's really small. And for women also in older age, it's really small. So we focus, since the general fertility rate in the previous slides, on women between 15 and 49. But even between 15 and 49, women have smaller, higher chances to have children. Women between the ages of 15 and 19 have smaller chances of having children compared to those between 20 and 24. Usually you see higher chances of having children among women between the ages of 25, 29 and 30, 34, right? And in some countries you see more postponement in fertility, also high rates around 35 to 39, but usually it's between 25, 29, 30, 34. What about if a population has more women in a specific age, sub-age group of these ones here? So in order to take that into account, in order to take the age structure into account, we can estimate these fertility rates specific for each age group, which are called the age-specific fertility rates. So here we need more detailed information. We will need the number of births that were experienced by women in each one of these sub-age groups, and the overall number of women in each one of these age groups, right? So I'm pretty much estimating birth rates of women according to their ages. And usually the age-specific fertility rates are calculated for women in each one of these 7 5-year age groups. Sometimes if you have really reliable data and you know you have a big sample and you have women reporting their ages correctly and the number of children that they have correctly, then you can estimate age-specific fertility rates for every single year between the ages of 15 and 49. So you could have 35 age-specific fertility rates for every single year, but that's usually not common to do it. And here, the age-specific fertility rate, symbolized by ASFR, has these two symbols here, the X and the N. And that's the standard notation of demographers. Can be a little misleading, but that's the usual notation that we have in demographic formulas when we are talking about formulas for specific age groups. The X means the starting age that we have, and the N means the width of that interval. So for this age group here, 15 to 19, you have ASFR 15, 5, because 15 is included. So it'll be 15, 16, 17, 18, 19. For the age group of 30 to 34 is ASFR 35. So the N is the same, right? It's just saying the N is the width of the interval. Like I said, in order to estimate these rates, we need the number of births that were experienced in a specific population in a specific year for women in each one of these age groups. And also the denominator, the total number of women in the middle of the period for each one of these age groups. We usually multiply it by 1,000 because we also get small numbers, so it's easier to interpret when we multiply by 1,000. Overall, the general trend of the age-specific fertility rates is to have an inverted U shape. So if you get the age-specific fertility rates and put in a graph, the horizontal axis, you have the age groups, the 7 age groups, and the vertical axis, the rate. The rate increases with age and then declines afterwards with age, right? So in an inverted U shape. This is an example, all right? We have the age-specific fertility rates for Africa for the years 1970 to 75, and then 2005 to 2010. What we see here, the inverted U shape. Women between the ages of 15 to 19 have lower chances of having children than the ones from 20 to 24. 25 to 29 have almost the same, increasing a little bit, and then it starts to decline. The same thing we observe here in this more recent period. So that's the first thing that we notice here, the inverted U shape. Second thing, we see that over time, the overall fertility has been declining, right? The pink curve here is lower than the green curve. So the level of fertility has been declining. Third thing that we see in the graph, this decline was more pronounced exactly among women that have higher chances of having babies. 2024, see the distance from here to here, and the distance from here to here, 25 to 29, is wider than this distance here, than the distance in older age groups. Inverted U shape, fertility decline over time, and this decline was more pronounced exactly among women that have more children. And a fourth thing that we see, look here. It's not so pronounced here, we can see in another graph, but 20 to 24, the rate of the chance of having children among women in 1970 was really close to those 20 to 25. It increased a little bit, but not so much, almost the same level. What do you see now here in 2005, 2010? This woman is still having lower chances, but this curve here is steeper than we see here. So this woman here, the decline in fertility over time was stronger. This decline here was stronger than this decline here. So that's an indication that women between the ages of 20 and 24 are postponing the ages in which they have children. Postponing to older ages, to the ages of 25, 29, or even older ages, right? This is more clear when we look at the graph in Europe. In Europe, 1970, 75. Again, inverted U shape, increase from 15 to 19 to 2024, and then start to decline. 2005, 2010, the same thing. Second finding, fertility declines. Oh, wait, not so simple. Fertility declines in younger age groups, but it kind of increases a little bit at least in older age groups, right? And kind of remains the same in the last age groups. Another thing, the decline was more pronounced in the age group of 20 to 24. This decline here was much wider than this one here and than this one here. And fourth, now we see really clear postponement in the ages of having children. The highest chances of having children in Europe back in 1970 was clearly among those between the ages of 20 and 24. And now in more recent years, 2005 and 2010, ages of 25 and 29 and even 30 to 34 have higher rates than 20 to 24. The rates of fertility decline so much more in Europe than Africa by these same time points that you see a really clear postponement in the ages of having children. Younger women postponing the age in which they have children to older ages. This is an indication because I'm not following exactly those women over time. This is cross-sectional data, okay? This is too much information, right? Too many data. Like 7 rates of fertility because we have the 7 age groups. Can we summarize them in one single indicator? We usually summarize the age-specific fertility rates into the total fertility rate, which is the most popular measure of fertility. Also, usually is cross-sectional. Get information about how many babies women had in a specific year by the age group of the woman, divided by the number of women in each one of these age groups. And then we combine these age-specific fertility rates. But we could also follow women over time. If we have resources to follow the same woman over time and see how many children that they're having as they get older, we could calculate total fertility rates for specific cohorts. Cohort of women that were 15 years of age in a specific time point and then follow them through time. This kind of analysis would be more expensive because we would have to go and collect information for each one of these women. Through time, I cannot just collect information from one specific time point to calculate cohort data. In that case, if I have data from one time point, I have cross-sectional data. So how do I explain what this total fertility rate means? And here comes one example of a hypothetical measure in demography. It's going to be the same kind of interpretation for life expectancy at birth. So it's important to understand that. Something that I already mentioned in the previous lectures, but here's a really clear example. Is the number of births that a hypothetical group of 1,000 women would produce during their reproductive years. And how do you calculate that? You pretty much just get the age-specific fertility rates and you multiply by the width of the age group that we usually have 5, the width of the age group, 15 to 19, 20 to 24, and so on. And we add them all to get the total fertility rate. Usually the total fertility rate, if previously you multiply the age-specific fertility rate by 1,000, usually after we do this calculation here, we divide the total fertility rate by 1,000. So it would be the number of births that a hypothetical woman would experience if she lived throughout her reproductive ages with the risks of having children as measured by the age-specific fertility rates. Why is this hypothetical? And that's important to understand. A woman who is 20 to 24 in 1970, 1975, 5 years later, in 1975, 1980, this woman would be 25 to 29 years old. But she's not going to be exposed to this chance here of having children. Because in 1975, 1980, these rates will change, right? Same thing here. If a woman who is in 2005, 2010, 25 to 29, she's experienced this chance here of having children. 5 years later, when she is 30 to 34, this is not going to be the chance of her having a child in that age group, because she's going to be 30 to 34 in 2010, 2015, right? So when we get the cross-sectional data for one specific time point, 2005 to 2010, and we combine all these age-specific fertility rates from this pink curve, we kind of like saying, if we get a hypothetical group of women and expose them to these chances here of having children, 15 to 19, 20 to 24, 25 to 29, and so on, they would have on average a specific amount of children per woman. So why is this hypothetical? Because these women here, 2024, in 2005, 2010, when they reach this age group here, this is not going to be the rate that they will have. It's going to be a different one, because now it's going to be already 2010, 2015, when they reach this age group. So when we get age-specific fertility rates for one specific time point, combine them in this formula, we are saying, let's expose a hypothetical group of women to these rates. Why is that important? Because we are getting the experience of women in a specific time point, in a specific population, and seeing the overall level of fertility in that population. And if we do the same thing for several years, we can see the trend over time. Okay? The same thing we're going to talk about in mortality, life expectancy at birth, when we talk about mortality rates. Same thing here with fertility rates. And that's one thing that I discussed, I think, in the first set of slides of this course in the semester, right? Is using this period data to create these hypothetical measures of a hypothetical group of people experiencing these rates throughout their lives. In this case here, a hypothetical group of women experience fertility rates throughout their reproductive ages, 15 to 49. Example of total fertility rates for the US between 1911 and 2011. Usually you see really close associations in the level of total fertility rates and overall economic dynamics that are going on in the countries. So you see here during the Great Depressions in 1930s, when people lost their jobs and a lot of poverty in the world, and specifically in the US as well, people, when they are experiencing those harsh economic conditions, they tend even to postpone marriage and don't have children during that period if they are married. So the total fertility rate tends to decline. And how do we read this number here? If we got the age-specific fertility rates from 1911 and exposed this hypothetical group of women between the ages of 15 to 49 to those age-specific fertility rates, they would have had on average around 3.4 children per woman. Right? We already divided by 1,000 if their specific fertility rate had been multiplied before. And it dropped to like around 2.1, 2.2 during the Great Depression. And then can you still hear me in the microphone? That's just a Windows thing, I think. And then we have the period of the baby boom. After the World War II, you have economic development, economic prosperity in the country, people having better jobs, better earnings, and then fertility increases, right? When you experience the energy crisis in the 1970s, you see a drop in fertility. It bounces back a little bit, it goes back up a little above the replacement level. And remember the replacement level, 2.1, if we have a total fertility rate below 2.1 children per woman, we say that that country or that population is below the replacement level. Why 2.1? 2, because the woman is producing babies to replace both her and her partner, right? 0.1, because some of these babies, mostly we are more concerned here with the daughters, they will not reach the childbearing years, the ages of 15 to 49. So they will not be able to replace the generation of their mothers because they will not reach older ages, reproductive ages. Another thing, of the reason of the 0.1, sex ratio at birth is usually above 100%. We usually have more baby boys being born than baby girls, even in countries that there is no preference for sons. So you have to produce a little bit more girls, a little bit more overall children than 2, in order to have enough daughters to replace the generation of mothers, right? And then you see that during the 1970s, the US experienced declines in fertility so deep that it went below the replacement level. Then kind of went up in the 1990s and 2000s. And even now, in 2008, after the Great Recession, we see again a drop in fertility. With all the housing crisis that we experienced in 2008, 2009, since 2007 to 2009, people having economic issues, and then you see also a drop in fertility rates. And people were talking, I mean, at the beginning of the pandemic, oh, this pandemic is making people staying at home because of the lockdowns, that will increase the chances of people having children because they're at home the whole time, the couple. People who say that, they just don't understand demography, right? Because what did the pandemic caused? Right after the beginning of the pandemic, with the lockdowns and everything, you saw a huge impact on the economy, right? Public health affecting the economy. Unemployment rates increased a lot. Unemployment rates increasing a lot. People are scared. They don't know what's going to happen these next years. They kind of cancel their plans of having children if they had any, right? So what you would expect in this case during the pandemic, and now that's where we are getting data to analyze that, is a drop in fertility because of the pandemic, because the pandemic is associated with these economic issues that we experience in the country. And if the couple is having more sex at home because they are in the lockdown, we have contraception if people don't want to have children. And that's widespread in our society. It's all things that we're going to discuss when we talk about determinants of fertility, right? So just some preliminary estimations. So this is just a news article kind of mentioning that fertility has been dropping a lot over time here in the US. And even teenage births have dropped a lot from 2007 to 2018. And we reached a record low of 1.7 births per woman in 2019. But even with these low levels of fertility in the US, so here we have exactly the total fertility rate dropping to below the replacement level, right? And now when we read this, where was that? Below the replacement rate, below the replacement level of 2.1. That's the number to sustain populations for the future generations to replace the previous generations. So that's what these terms mean. But now during the pandemic, what you are seeing already is a drop in fertility by around 4.4%. So these early estimations here from March last year, there were about 95,000 fewer births in 2020 compared to 2019, right? So it's important to analyze fertility with a more scientific understanding of the society. And based on previous findings, if we look at this, we understand we have a good hypothesis of what's going to happen to fertility because of the pandemic. Previous studies give me a theory, and then I have a hypothesis. And the major changes, so 34% of American women have either put off their plans to have children or reduced the number they expect to have. There may rebound when the pandemic ends. So now we might see increase a little bit back to the regular fertility rates that we had before, but it's all an open question. People are trying to estimate those by now. And if countries don't have the population broken by sex and doesn't have the population broken by age group, how do I calculate the total fertility rate? That's really rare nowadays with more recent data. But let's say that I analyze a developing country for some decades ago. I might not find the population of women. I just have the overall population. I might not find the population broken down by age group. I just have the overall population. In that case, I can just calculate the crude birth rate. And if I multiply by 4.5, that's an approximation to the general fertility rate. And I go further and multiply by 30, that's an approximation to the total fertility rate. Let's say that I do have the population by sex, so I can get information about only women. But let's say that I just have the population of women between the ages of 15 and 49. I don't have the population of women for each one of the specific age groups. So I can calculate only the general fertility rate. If I multiply by 30, that's also an approximation to the total fertility rate. Of course, these numbers would not be exactly the same number if I had the more broken down data, but that's an approximation. And usually for total fertility rates, we prefer to calculate period total fertility rates instead of cohort total fertility rates because it tells us the level of fertility in that specific time point. Like I showed the graph here for the US, and then we link the trends. We can better understand the trends of total fertility rate, understanding the socioeconomic context of that population, right? Exactly what we saw in this graph here. And when we talk about all these discussions about fertility, we are always back of our mind trying to understand how the level of fertility is right now compared to a situation in which women would not try to control their fertility. All women were engaged, were sexually active, no use of contraception, healthy. What would have been their fertility in those conditions? So that's related to this concept of natural fertility. It's the level of reproduction in the absence of deliberate fertility control. So Henry, Cole, and Trussell, they estimated the natural fertility to be around 6 or 7 live births per woman. And around 25% of completed fertility is due to genetics, the same as mortality. But 75% is related to use of contraception, of postponing the fertility, of having a health diet, and so on. So there are a lot of ways that people can make fertility go down. But then this specific community, the Hutterites, using their data from 1930s, demographers would see that they had on average 11 children per woman, even higher than what these previous authors had suggested being the natural fertility. And the Hutterites are an ethno-religious group that was formed in the 16th century. Really religious group. They live in specific communities that nowadays are located in South Dakota, North Dakota, Montana, and also in Western Canada. Really typical here in the US to have these communities, religious communities living by themselves with their habits and everything. And this specific group here is categorized by having early age at marriage. So people get married early and engage in intercourse with the partners, right? Good diet, good medical care, regularly engage in intercourse without contraception or abortion. So what's the difference between this group, for example, and some societies that we have still nowadays, usually more developing countries, that still have early age at marriage and still low, or at least low levels of contraception? The thing is, like those societies that we see nowadays that still have high levels of fertility, not 11, not a total fertility rate of 11, but it's still high, around 6, 7 specific countries. Why they don't reach even higher rates? Maybe there is early age at marriage, regular engage in intercourse. Some of them might use contraception, but it's still really low levels of use of contraception. But in those contemporary societies that still have high levels of fertility in developing countries, usually those populations do not have good diet, do not have good medical care. So this problem here makes that fertility already drop below the level of natural fertility, right? Example, getting the data of the Hutterites back in 1930s. The total fertility rate equals to 11. So if we exposed a group of women to the age-specific fertility rates measured for the Hutterites back in 1930 and expose them to these rates here, they would have on average 11 children per woman. And the age-specific fertility rates are shown here. And these are multiplied by 1,000. So for every 1,000 women between the ages of 15 and 19, back in 1930, in this group, 250 of them had children. It's a lot. Out of 1,000 women in this age group, 460 of them had children. This group here, out of 1,000, 431 had children. If we get these numbers here and put in this graph, that's exactly this curve here, really high levels. How do I know those are high levels? If I compare to more contemporary societies. In this example here, from this other textbook, getting data from Mexico, US, and Canada. For every 1,000 women in these specific age groups, in this specific year, we had 63 births among Mexican women between the ages of 15 and 19, for example. Even lower levels in the US and Canada. See these numbers much lower than among the Hutterites. Total fertility rate in Mexico at that time, 2.2 children per woman. In the US, 2 children per woman. Canada already really below the replacement level, 1.7 children per woman. Putting the age-specific fertility rates that are shown here into a graph format, you see Mexico still with high levels of age-specific fertility rates among younger women comparing to these other older ones here. But of course, much lower than when you compare to the natural fertility taking the fertility of Hutterites as this measure of natural fertility. The US already lower levels of fertility than Mexico, back with data from 2010, and Canada also lower levels. But you see that for older age groups in the US and Canada, women between the ages of 30 to 34, in the US and Canada, these numbers are higher than in Mexico. These numbers here are higher than in Mexico for these two age groups. Exactly because now we have in the US and Canada, since the 2010, a postponement in the age in which people have children, in which women have children. Of course, Mexico is also experiencing that, but here we see that the US and Canada experienced postponement in fertility earlier on in time compared to Mexican women, okay? What are the causes that make these contemporary societies have much lower levels of fertility than the natural fertility that was measured among the Hutterites in 1930s? For now, we are just measuring the fertility rates. Why did they drop? Why we have postponement in fertility? Why? What are the factors? And that's going to be the second portion of this lecture, trying to understand what are the factors that make fertility decline and make also women postpone the age in which they have children, right? Another rate that we can estimate related to fertility, the gross reproduction rate. When we had the crude birth rate. The numerator and the denominator had both men and women. The numerator, baby boys, baby girls. The denominator, men and women, the overall population. Birth. Fertility rates. The numerator is still related to baby boys and baby girls, but the denominator is now what? Only women. So the term fertility rate instead of birth rate, now because we are talking about fertility rate, the denominator, it's only women. No man in the denominator, but it's still baby boys in the numerator and baby girls in the numerator as well. When we are talking about reproduction rate, both the denominator and the numerator, we are just talking about women. Women in the denominator having the baby daughters in the numerator. So reproduction rate, we are including only female births in the numerator. And that's related to this concept of population replacement. Here now, I want to know if on average, women are having at least one daughter. If women are having at least one daughter, that means that that daughter will replace them in the coming years to also reproduce and so on. Here, since we are just counting the daughters, not the sons, we don't have to deal with that problem with sex ratio, right? Because we are already counting only the daughters, not the sons. But we're still not taking into account that some daughters might die before they reach reproductive ages. At this point here, I'm just doing the female births per woman in the age group that goes from X to X plus N. And I do the same thing as before. But now, for a woman between 15 and 19 years of age, I have to calculate, I have to get the data of how many of those births were daughters. Take out the sons, right? The sons don't matter here, just the daughters. The calculation of the gross reproduction rate is really similar to the total fertility rate. The difference is that now the numerator of this rate here, I'm getting only daughters, right, that were born in that specific year for each specific age group. And the width of the age group is usually the same one, 5, for those 7 age groups, 15 to 19 until 44 to 49. And the gross reproduction rate, if we don't have so refined data, if we don't know exactly for each age group of the woman how many daughters they had, but let's say that we have the total fertility rates, and we know the overall number of daughters that were born in that year. And we also know the overall number of births. We know the overall number of births and the overall number of baby girls being born. In this example here, 0.48. So out of all births in this example here, we have 48.8% of daughters being born and 51.2% of boys. I just use this formula here in the case that I do not know the exact number of daughters being born for women in the 7 5-year age groups. If I don't have that, I can use this approximation. And what is this number here, 0.488? Where this magical number comes from? Is based on the sex ratio at birth of most countries. Most countries have a sex ratio at birth of 105. That's that biological normal that we talked before. 105 baby boys born for every 100 girls. And how exactly did I get from 105 to 0.488? So the proportion of female births, here represented by the FFAB here, equals 1 minus the proportion of male births. How can we calculate the proportion of male births? If the sex ratio at birth equals 105, we have 105 male births for every 100 female births. So 105 male births divided by the overall amount, 105 plus 100. This number here gives us the overall proportion of male births, 51.2%. 1 minus that, 0.488, 48.8% of female births. In some Asian countries, for example, in China, and when you have sex ratio at birth much higher than 105, we should just use another constant. If we have a country with a sex ratio at birth of 120, we just substitute here in the formula, 120 and 120 here, and we get the proportion of female births. But for overall, the countries, we use the 0.488. I mentioned, this formula here is now counting only girls, so we don't have to take into account that more boys are born when we want to calculate it. So we are counting if this number is below 1 unit, women are not having enough daughters to replace them in the future generations. Wait. But when you talk about the 2.1 replacement level in total fertility rate, you also said some of these daughters will not reach reproductive ages, will not reach the ages of 15 to 49. So how do you take that into account? We do it with the net reproduction rate, right? It considers the effect of mortality among mothers from the time of birth of their daughters. So some women we are now analyzing them, they themselves might die before reaching 49 years of age. A woman who is now 15 years old, she might have had a daughter now, and she might die before reaching 49 years of age. So we have to discount the mortality of that mother. By discounting it, the net reproduction rate will always be lower than the gross reproduction rate because we are taking into account mortality. So we have the same as before. Now we are having the net reproduction rate. We have the female births per woman in the age group, female, age-specific fertility rate, so the number of daughters that were born per groups of women in each one of these age groups going from X to X plus N. We also multiply by the width of the age group, as we did before. But now we take into account mortality. We take into account that some of these women will not reach the end of their reproductive ages, will not reach 49 years of age. Some of them will be alive from 15 to 19, but then will die before reaching 2024. Some of them will die before reaching 25, 29, and so on. We have to discount that. This measure here, it's going to be more clear when we discuss life tables in the mortality chapter. But basically, what this number is giving us is the proportion of people who survive from age 0 to the midpoint of each of the 7 age intervals. Which are the 7 age intervals? 15 to 19, 20 to 24, 25 to 29 until 44 to 49. 7 age groups. And this little L0 is the number of people at age 0. And usually in life tables, we have this L0 is the radix, it's called radix, R-A-D-I-X. The radix of the life table is the overall number of people that were born in a specific year. In this case, the overall number of women born in that specific year. 5, we are multiplying here by 5 because we have 5-year age groups, right? We are doing 15 to 19, 20, 24, 25, 29, and so on. And then what's the number of people who survive into a specific age group is measured by the big LXN. So the little L0, and these are the terms used by demographers, the little L0, which is the radix, and the big LXN. The big LXN is going to tell me the number of people, the number of person years that this group of women who were born in a specific year past then will live in that specific age group. Which age group? The one going from X to X plus N. So the big LXN, we're going to have one for each one of the age groups. 15 to 19, 20 to 24, 25 to 29, until 44 to 49. The L0, the denominator, is going to be always the same here when we calculate in a specific population in a specific year. But then we are counting how many women are surviving to and are living throughout each one of these age groups. So the big LXN is the total number of person years lived in the age group. If a woman was alive when she was 15 and was alive when she was 19, she lived all the age group. So she lived a total of 5 person years in that age group. So she will count 5 divided by the 5 years that she could live. If a woman was alive when she was 20 and died when she was 23, in the age group from 20 to 24, she was alive for 4 years, 20, 21, 22, 23, out of 5. So she will count as 4/5 right here. And we just have this overall measure for the population or specific population in a specific year. What you have to understand here now, basically the difference between the gross reproduction rate and the net reproduction rate is that now we take into account mortality. Some of these women will not live until the end of the reproductive ages. So we have to discount that. This number here is going to be below 1. By being below 1, this net reproduction rate will be lower than the gross reproduction rate. And using this information of net reproduction rate, we can calculate the mean length of a generation. The mean length of a generation is the mean age of mothers giving birth to live daughters with current age-specific fertility and mortality rates. We are still talking about the fertility rates of only just counting the daughters in the numerator. We are taking into account mortality, the proportion of people who survive from age 0 to the midpoint of each of the 7 age groups. We are taking into account the width of the age group, and we also take into account the midpoint of the age group. For example, from the age group from 15 to 19, or 20 to 24. 2024, the midpoint is going to be 22, right? 20 plus 24 divided by 2, okay? By getting this information, all this here is similar to the net reproduction rate. But now we multiply by the midpoint of the age group and divide by the net reproduction rate. That will give us the average age in which women are having their daughters. If they're having it at younger or older ages, we can analyze by estimating this. So this part here, it's just about estimation of fertility indicators, right? Fertility rates. You're just calculating the rates. Then afterwards, we're going to talk about what are the reasons of fertility has been declining and give examples about the world and the US. And just as examples of how to measure fertility, in the course website, when you go there to the portion about fertility, here, you have examples of fertility rates in Excel. When you download this, it's a compressed file that's going to have 2 Excel files within it. This fertility rates in Brazil and fertility rates in the US. The one in Brazil is simple. I'm just getting the female population by age group for each one of the 7 5-year age groups. Got it from 1994 to 2005. Got the number of births that they had, both baby boys and baby girls, and then divide one by the other to get the age-specific fertility rate. So this one here, I'm getting the data from the births tab divided by the information from the female population tab in my Excel file. I do the same for everything. Here I'm not multiplying by 1,000. So if I just add them all and multiply by 5, because that's the width of the age group, I get the total fertility rate, right? And if I want to plot this information here of age-specific fertility rates, I have these rates plotted in the graph. Of course, here I have so many years that gets all messed up, but gives us also the inverted U curve, women between the ages of 20 and 24 having the higher rates. And since I got like really a short period of time from 1994 and 2005, we see kind of like increase here and then decrease again. But if we get it from 1970, 80, 1990, 2000, 2010, then we're going to see an overall trend of declining fertility. And then this file here for the US, I go in more detail and give example of how to estimate each one of the rates that I talk now in the lecture. But in this case here, I'm just showing calculation based on data from 2012, only one single year. And the data that I had to get to make the calculation here in the spreadsheet is the one highlighted in yellow. So the cells in yellows are raw data that I had to collect. And I got data from this textbook, pretty much from these truth tables in this textbook. I have the number of women in each one of these age groups, the number of births to women in each one of the age groups. So this both baby boys and baby girls. Out of these 305,388 babies being born. 149,182 were girls. So this is information they also had to get. Number of female births to women in the age group. And this is the information from the life table about mortality that I get out of the 100,000 women that were born from my life table. How many person years did they live in each one of the age groups? It's measured here. Remember, we have 5 years within each age group. If there was no mortality, all these women here lived from 15 to 19 and lived it throughout. How many person years would we have? 500,000 is 100,000 times 5. But for all of them, we see that the number is below 500,000, meaning that women are dying. And then we get this information into account to estimate the net reproduction rate. And I will go more in detail, take more time in this specific spreadsheet, the beginning of our class on Thursday, and I will continue on this lecture about fertility, okay? Thank you very much. There is no quiz today because it's the first lecture after the exam, and I see you guys again on Thursday. Thank you.